Welcome back to the channel. Hope everybody's doing well. And in today's video we are going to take a look at the 1/2 inch drive torque wrench from Teng Tools. This is from their Plus range, 40 to 200 Newton meters torque range, and essentially this is the big brother of the little 3/8 inch torque wrench I tested and looked at a while back. Got some excellent results with that, very happy with that one. All the torque measurements I made were within 1% of the nominal values, so very good. I went out and purchased this 40 to 200 Newton meter one, as some of the work that I do, especially on transformer bushing turrets and sometimes actual busbar connections themselves, they will go above 100 Newton meters, which I can only use that one if I start using torque adapters or a torque multiplier. So as per the 3/8 torque wrench, it comes in a blow molded case, exactly the same case in actual fact, has the same kind of blow moulding that can fit either the 3/8 wrench or the 1/2 inch and probably the 1/4 inch drive as well. You get a little bit of foam padding in there to keep it secure. You get the little hanging clip that goes into the handle of the torque wrench. It clips into these side holes here on either side. As per the 3/8, once you clip that in there, this then won't sit inside the case very well, so I tend to leave it out. And that is the case. On the lid there you've got the part number, which is 129-2P200, and then at the other end we have the actual range of the torque wrench. You also get this certificate of conformance, calibration certificate for want of a better phrase really, plus or minus 4% tolerance. However, the 5 values they've measured at: 40 Newton meters was 39.95, 120 Newton meters was 118.47, and 200 Newton meters was 202.48. So again, another set of excellent results from their tests. Unfortunately, as we see, I haven't been able to repeat that, and as I've used this wrench more and more, this has got more and more out of tolerance that I haven't seen with the 3/8 drive. To set the wrench, we have the adjuster down at the bottom here. The lock button, so again, it's just a little lever that you press to open and to lock, and then you can turn this. These are in single digits on the bottom scale here, and then your main scale, nice and clear, but only in Newton meters. The head is ratchet head. You can reverse it, but you can only torque up in the clockwise direction. Okay, so that's the wrench. We'll move the camera over so you can see the screen on the Dremel test. So I have tested at slightly different values to the certificate. So we have our first set in there, which is 50 Newton meters. Hopefully we can see, and we are on R0 at the other end. And we'll get to see what happens with some values. So we have 46.1. 46.1 again, 46.1 again. So the values for 50 Newton meter setting should be somewhere between 48 and 52, and you can see we are not getting that. We are also out at 40 Newton meters, which hopefully we can show you there. Set to 40. 36.8, and we should be 38.4 to 41.6 on that one. Go to our 60 Newton meters. Our 0 there. For 60 Newton meters, we should be between 57 to 62. And we are 55.9. We're reading low again. 70 Newton meters. There's our 70 Newton meters, 0, and we 65.4. We should be 67 to 73. 65 again. So you can see we are not doing very well at all. We'll take it to our 100 Newton meters, which we are 100 Newton meters there. There's our 0. And for this one we should be between 96 to 104. And you can see we just get in with that one. The bottom end, but we are within tolerance. Just. Let's do another one then, because that was a fraction below, wasn't it? Although my drummer test does read slightly low, so 95.9 will probably come up to 96. But you can see we're just on the bottom of the tolerance band there, 100 Newton meters. We will take it up to 190. From here on in it seems to be fine, but it is still reading lowish, so it looks like it could do with a bit of a tweak to take it within its tolerance band. And there's our 190 there, and then we are 0 there. So for a 190 Newton meter we should be between 182 and 197. So we'll give that a go. And we are 184, so we're in tolerance, but again we are down towards the bottom end. 185 again. So it is there. At the some kind of above 100 Newton meters, seems to be a little bit better, but below that it seems to have slipped out of tolerance. So just to test out our Ghidorah Dremel test here to prove that this is okay, we've set our 3/8 drive torque wrench to 50 Newton meters. There's the 0 on there, and previously this was very good, so we'll see how we go again. 49.5, so we are much closer to our 50 Newton meters. So I don't think there's anything wrong with the little Ghidorah test box. That's comparable to the results I was getting before for this 3/8 drive. There definitely seems to be an issue with our 1/2 inch drive torque wrench from Teng that's kind of developed over its usage really, that I haven't seen with the 3/8 wrench. So we'll put up the results tables and you can see what's been happening in a bit more detail. So here we are with our first set of tables. These test results are for when the wrench is new to me and I've hardly used it at all. Our top table are the actual measurements I've made, and that middle table there is those readings adjusted to take into consideration the tolerance of the Dremel Test E from its calibration certificate, and then the bottom table there is the tolerance calculations of those adjusted readings against the nominal setting. You can see that at the 50 Newton meter setting we do have 4 results that are out of tolerance, and the rest of the results are very close to the bottom limit there. When we got up to the 100 and the 190 Newton meter we were much better. They were all within tolerance, and all, what do you have, 2.33% was the worst deviation that I saw, but all the readings are pretty much below the nominal values. At the 190 we started creeping up a little bit. So apart from the 50 Newton meter reading being quite out, the other 2 readings followed the test certificate quite closely there really. The summary at the bottom there, against the 4%, 30 measurements, 4 are out of tolerance, 26 are in tolerance, that's an 86.67% there, and the average tolerance over all the readings was 1.88%. Move on to after the wrench has been used for a while, and you can see here same format with all the tables, so we can just jump straight to the bottom table there, and you can see that along that 50 Newton meter line all of them are out of tolerance, and I guess it's almost doubled really, hasn't it, by the looks of it. Minus 7% being the worst deviation that I saw there. The 100 and the 190 are just about within tolerance, but again in comparison to the previous set of readings you can see that they have all dropped. Our summary against the 4%, this time we had 10 out of tolerance readings, which gives us 66.67% in tolerance, and our average deviation is 3.37%, so actually quite close to the 4% tolerance, and much worse than the previous set of readings that I got. So yeah, it does look like something has changed within this wrench, and we are now seeing out of tolerance readings at the lower Newton meter values. These things are adjustable. There's usually a calibration setting within them that can be tweaked, so I'll need to take a look at that and see if I can bring it back up to within specification. But that'll be it for this video. Thanks very much for watching. Hope you found it useful, and I'll see you again in the next one.